In David Epstein's The Sports Gene, he talks about the Big Bang of bodies and how the athletic body has evolved since Kevin Norton and Tim Olds first began compiling data on the body types of athletes. It was once believed that the average sized human body was optimal for athletic sports performance. An athlete not too tall and not too small, neither too skinny nor too bulky. Researchers of the human body felt that human physique was distributed along a bell curve, and the peak of the curve, the average, was the perfect form, with everything to the sides deviating by accident or fault. So they believed that the best athletes would have the most well-rounded or average physical builds. But today, average is far from ideal. Could it be a change in the gene pool? Let's ask our friend David what his thoughts are.
The gene pool within competitive sports most certainly has changed. In the early half of the 20th century, physical education instructors and coaches had the idea that the average body type was the best for all athletic endeavors. Medium height, medium weight, no matter the sport. And this showed in athletes' bodies. In the 1920s, the average elite high jumper and average elite shot putter were the same exact size. But as that idea started to fade away, as sports scientists and coaches realized that rather than the average body type, you want highly specialized bodies that fit into certain athletic niches. A form of artificial selection took place, a self-sorting for bodies that fit certain sports. And athletes' bodies became more different from one another. Today, rather than the same size as the average elite high jumper, the average elite shot putter is 2.5 inches taller and 130 pounds heavier. And this happened throughout the sports world.
As digital technology, radio, television, and internet came about, consumption of elite sports performances became more accessible, and the interest in sports increased. As fortune, fame, and glory for elite athletes skyrocketed, it even further accelerated the artificial selection for specialized bodies in sports. The ideal body type for specific sports has changed greatly from the average body type. Here is a graphical expression of the differences in body types of specific sports. As it is now better understood how an athlete's size may give them an inherent advantage in a specific sport, studies are being done to see if an athlete's genetic makeup can play a role in helping them succeed in a specific sport.
So now we ask ourselves, to what extent may genetic makeup have been determining athletic specialization? A gene of interest that is currently being studied is ACTN3, which is associated with human elite athletic performance. This gene regulates the alpha-actinin 3 protein production and is associated with a higher fast-twitch muscle fiber ratio. There are 3 variants of the gene, XX, XR, and RR. We will be focusing on the 2 extremes, the RR and XX alleles. Those with the ACTN3 RR allele are protein efficient, producing the most protein, resulting in a higher proportion of fast-twitch muscle fibers. This increases fast muscle contractions used for sprinting and high muscle strength, so one will have a greater chance of succeeding in power sports like football, weightlifting, or sprinting. Those with the ACTN3 XX allele are protein deficient, producing no alpha-actinin 3, resulting in a lower proportion of fast-twitch muscle fibers. This deficiency suggests that one will be at a disadvantage in power sports as compared to those who have an RR allele. These people have a better chance of succeeding in endurance sports such as skiing, distance running, or swimming. This graph presents the results from a study done on Olympic athletes showing the correlation between power and endurance and efficiency and deficiency of ACTN3 alleles. The trends shown by the bar graph support what we would expect to see. The frequency of athletes who possess the XX genotype is slim to none in the power sports. As we look towards the endurance sports, the frequency of athletes who possess the XX genotype increases.
A study done by Heffernan was conducted on rugby players from the Rugby Union in the United Kingdom. They collected DNA saliva samples from the athletes and had a control group, and then divided the athletes into subgroups representing their respective roles on the field, forwards and backs. They wanted to see if each subgroup differed in ACTN3 genotype and how that affected their performance. The players who play the back position, known for their speed generation, had a higher proportion of the RR allele. The players in the forward position, known for their sustained endurance, had a higher proportion of the XX allele. Therefore, this study showed the correlation made earlier that speed is associated with the RR allele and that endurance is associated with the XX allele. With advances in genetic engineering, tests are now available to see whether a person is efficient or deficient in the ACTN3 gene. Parents can now test their children to see which genotype they hold. With this knowledge, parents can focus their children's attention on certain sports so that they have a better chance of succeeding in their niche. In result, this will further develop the evolution of the athlete.